Hello, fifth graders. Today we are looking at prime and composite numbers. So let's take a look at the meaning of those two words, prime number, composite number. Well, if a number is prime, the number is prime, that means it has only multiplication by 1 and itself to get that answer in multiplication. So, for example, if I have the number 5, the only way I can get 5 is by doing 1 times 5. I can't do it by 2, I can't do it by 3, I can't do it by 4, only 1 and 5. That makes it a prime number. In picture sense, if I had 5 squares, the only way I could arrange them is just like this, or flipping it and doing it the other way, right? Going up and down instead of side to side, a row or a column. That's the only way I could get that. That makes it a prime number. If it were a composite number, has more than just 1 and itself to get the answer. In multiplication. Now, this is my definition of it as far as for you, but it is also the idea that I can arrange things in more than one way to come up with that number, and even in an array. Remember, an array has the same amount going across as it does down, or same in each row, same in each column. So let's say I have the number 6. The number 6, I can take and I could put 6 in a row. Okay, 1, 2, 3, 4, 5, 6, 7. Nope, we just want 6. Okay, 6 in a row. Or I can do this by 2s, 2 in each row. 2, 4, 6. I can do, which is the same as 3 by 2, right? I can do it by 3s like this too. And then of course the other way for this one is just up and down. If I put a dividing line in between these. Alright, so you can see them in different sections. 1, 2, 3, 4, 5, 6. Alright, so really what we have is we have 1 times 6, or the same as 6 times 1, or we have 2 times 3, or 3 times 2. We only put 1 once because we don't need to have them in multiple times. So I could use 1 and 6 or 2 and 3 to get to 6. That makes it a composite number. Okay, so a composite number is going to have more than just one way to get that answer. A prime number only by itself. Okay, and we can draw arrays like I did here to try and come up with whether we know something's a or a composite or a prime number. We can use different pairs. This we call this different pairs of numbers there to come up with it. We can use this pair or we can use this pair to get the composite number. A couple things that can help you to understand whether a number is composite or prime. I'm going to go over just a few of these rules with you, okay? So you can see those prime numbers and composite numbers. How do I know for sure? Well, the first thing is if we have a multiplication chart, okay? A multiplication chart, anything that's in that center section here, that it's multiplied by 2, 3, 4, 5, 6, 7, 8, 9, 10, any of these numbers here are not going to be your composite numbers, because it's going to have other numbers besides 1 in itself to get to it. Anything starting with 2 by 2 through 10 by 10 on this chart, all those going to be counted off. But let's look at just some basic rules for it. How do I know if it's prime or composite? Well, sometimes it's easier to tell whether it's composite or not. So composite, besides 2, if it is an even number. Because we know that when we have an even number, I can divide it by 2, or I can multiply 2 by something to get to that number. So if I had a number like 6,489,212, is it composite or prime? It's definitely not prime. Not prime because it ends in an even number. Doesn't matter what all the other numbers are, it ends in an even number, so it is not a composite. And again, besides 2, 2 is our only even number, that is a composite. Okay. Now, when you're looking at double-digit numbers, any 2 plus, that means just 2 or more numbers, any 2 or more numbers that end in 5. Any 2 or more numbers that end in 5. For example, 35 or 1,285. Okay, both of those are composites because they end in 5, and that means they can be divided by 5, or that there's a number times 5 that would give me that number. Okay. Another one, if you add the digits, and they equal 3, 6, or 9. If you add the digits and they equal 3, 6, or 9, they're composite. Because remember, when you add the digits and they equal 3, 6, or 9, then they are divisible by 3. If they equal 9, they're divisible by 9. So that makes them not prime. Okay? When you look at numbers in general, you're probably going to have more, you do have more composite numbers than you do prime numbers. Looking at our list of primes from the beginning, if we just take a chart and start writing down our numbers, 1, 2, 3, 4, 5, 6, 7, 8. Let's just do up through 20. Okay, we'll just look at numbers up through 20. And then we'll see if we have all that covered. Okay. All right. So here's our numbers, and we're looking at prime and composite numbers. All right, prime and composite numbers. So when I look to see is a number prime or composite, I can start to cross off certain numbers. So we just said any even number besides 2. So we're leaving 2 alone. Even number, even number, even number. Cross them all off, right? Count by 2s, we cross off all those even numbers. Okay, so they are not prime. Looking for prime. Okay, so the next set of numbers, anything that ends in a 5, that's not 5, if it's 2 digits or more. So I have this number here, I cross that out. Okay, then I have digits that equal 3, 6, or 9. Well, except for up in the front again, we've got to keep going here. 3, I leave alone because there's nothing I can multiply 3 by besides 1 to get 3. So any other numbers that equal 3, 6, or 9. 9 does, so we can cross that out. 1 and 1 is 2. 1 and 3 is 4. 1 and 7 is 8. 1 and 9 is 10. So that doesn't work there, and there's no other numbers that we haven't already crossed out from the first two rules that we would need to cross out here. So for that, then I'm done with my prime numbers up through 20. So I have 1, 2, 3, 5, 7, 11, 13, 17, and 19. Because I can't multiply anything together to get those two numbers, or get that number, except for 1 and itself. Now, if you're not sure about this, I would encourage you to just get out some counter type things, maybe, you know, Cheerios or snack, or even, you know, little things that don't roll around though, because you don't want them to, even puzzle pieces, whatever you want, and see if you can make up the idea of the prime numbers. If you're trying to look for that prime number, if you weren't sure if 19 is prime and you did your 19 going across, well, can you do it by 2s? 2, 4, 6, 8, 10, 12, 14, 16, 18, 19. Oh, nope. They need to have a partner. He doesn't have a partner here. There's a space missing. So can't do anything by 2s. Then you can try it by 3s. 3, 6, 9, 12, 15, 16, 17, 18, 19. Nope, that doesn't work because we have 2 spaces missing, people. And then we could do it, we can try it by 4s and 5s and 6s and so on if you wanted to try and figure out if you weren't sure if 19 was a prime number or not. Okay? But for the most part, going through those rules and looking for those prime numbers, thinking about, can I multiply 2 times something, 3 times something, 4 times something. When you get halfway, you don't have to go any further if you're talking about looking at your multiplication facts. Because when I get to 5 times 2 is 10, and then I try to do 5 times 3, 5 times 4 times, oh, nope, it's too big. The number's too big. So when you look at that, just think, are there any ways that I can get that number besides 1 and itself? And that's going to be your prime numbers. So the numbers in purple here that you see, those are your prime numbers. The ones that are crossed out are examples of your composite numbers. Okay? You have a worksheet today that's dealing with lesson 80. And if we go over some of that together just to make sure you understand what you have to do in lesson 80, you have number 1, you're looking for the cost of the profit that the store makes. So you want to remember, take how much is spent minus how much they how much they sell them for minus how much they bought them for. 3 is an example of those, write the numbers that are factors of 8 and factors of 12. So come up with your multiplication facts, and whichever numbers are the same, whichever ones are in both, those are your factors of both. And that's where I want you to write that. For 4, the next prime numbers, it says 2, 3, 5, 7, 11 are prime. What are the next 3? So the next 3 prime numbers. Number 6, coming up with fractions that are equal to the numbers that they give, add them together, and then write it as a mixed number. All right. So if you get like 13 over 6, then write it, you know, with as 2 and 1/6. Okay. When you get down to 10, you're using that number line. Make sure you put millimeters as your answer. Subtraction. Another one with 6 times W equals this. So this divided by 6 equals W. And find for W. Okay, on this one, 2 to the 6th power. Remember, the 6 means that I have 1, 2, 3, 4, 5, 6 number 2s. 2 times 2 times 2 times 2 times 2 times 2. All right, and make sure that you have that so that you know that 2 times 2 times 2 times 2 times 2 times 2. It's not 2 times 6. All right. Then find your square root, and then add those two answers together. Find your answer here, write it as a mixed number. So remember, it's your remainder over your divisor for what it's like as a mixed number. So whatever your answer is with your remainder over your divisor. Multiplication of fractions there. Equivalent fractions like you did yesterday, 10 times what is 100, then do the same thing for the top to find your answer there. For number 23, it's 5 minus 1/5. So what I want you to do is change that 5 to a mixed number first. So we would take one group away from that and we'd have 4, and then in order to have 5 total, we want to have 5/5. 4 and 5/5 is the same as 5. We want to change that to 4 and 5/5 before we do that subtraction. We need to have a fraction here in order to subtract that fraction from it. Okay. All right, 26 is fine the way it is. 28, is the sequence arithmetic or geometric? In other words, look and see, do you multiply or do you add to get to the next number? If you're adding the same number each time, then it's arithmetic. If you're multiplying that number by something, then it's geometric. And you need to put the two numbers you need, and then whether it's arithmetic or geometric. And you can go back to investigation 4 in your book to help you with that. Okay, with 29, it's going to be it says what is the probability that the captain was right, so this needs to be a fraction. So make sure that 29 is a fraction that you're writing down. Okay, so that's what you need for 29. And you're not doing 30, so that's it. I hope you are having a good day, and we'll talk to you soon.